So the ultimate goal of analytics is to explain what has happened or predicting what will happen in order to make effective business decisions. When we predict revenue, we're forecasting out what's going to happen, say, 3 months, 6 months, 12 months into the future or more. Or when we want to identify what may have happened in the past, for example, an increased number of errors in the production line, we may analyze historical data to see if there was something out of the ordinary or whether there was a random chance. In order to accomplish this goal, we must be able to analyze every one or every observation that can affect our results or can be affected by our results. And this poses a number of issues. Collecting data from everyone or every observation may not be physically possible. You just cannot survey the entire country or the entire planet, or you may not be able to test every single production item that comes off an assembly line. Collecting this data, even if you could do it from everyone, is just going to be cost prohibitive. So beyond the fact that you could actually do it if you could, it's just going to cost an enormous amount of money to actually execute that. The other thing is we may not have data from everyone because we haven't interacted with them. So there may be a general part of the population who's never had any interaction with our company or with our organization, and therefore we don't even know that they exist. Sampling, therefore, alleviates these issues by allowing us to use these statistical methods to make inferences about larger groups. Let's take an example. Assume we wish to understand how everyone in the United States will vote in a presidential election. Now, we know this happens all the time, every 4 years. The networks and other organizations are constantly trying to figure out how everyone is going to vote in an election. It should be obvious why this presents so many problems, from physically surveying everyone to the cost associated with surveying everyone. And in addition, respondents can lie about their tendencies for various reasons. They may not want to know, or they may be purposely lying to throw off results or believe that they can throw off results. So our goal will be to create a sample that would most represent the population of voters so that we can get a better assessment of what is actually going to happen. The group of interest in which we're trying to infer what will happen is called the population, and it contains the entire set or every member of the group for which we are attempting to draw this inference. When we draw a group from this population, we're trying to determine what are called the sampling units. The sampling units refer to the units of the prospective selection. So these are the individuals or items that are focused on what we're trying to identify. Finally, the subset of the population used for analysis to infer something is called the sample. And this is the subset of the population that we are trying to identify. Here's an example of the United States, and we have a number of voters here. We have 326 million people as of 2017. This population is just too big to survey. Therefore, we try and take a sample. But think of something like this. What if we only took people who were in New England? Would that be representative of the entire population? What if we only took New York or San Francisco and examined those voters? Would that be representative of the population? Would that tell us how the entire country is going to vote? And the answer is most likely not. So the sample that we choose should be representative of the population. If it is, then we're able to infer something about that population. So we want to make sure that we have individual pieces around the country that would have a somewhat representative sample of the United States, which should tell us in general how people will vote. Now, there are different types of samples and there are different ways that we can get a sample. However, the most common way is to generate some sort of random sampling, and it provides an equal chance that every member from a population will be selected. There are 4 different types of samples: simple random sampling, block random sampling, stratified random samples, and clustered random samples. The key to all of these samples is that there is a random selection component. And in Excel, we will create a random number by either using the RAND function or the RANDBETWEEN function. In Excel, the RAND function provides a random number between 0 and 1 from a uniform distribution. So recall from an earlier set of slides, we saw that the uniform distribution said that there was an equal chance of every number coming up, and it was the box diagram where we had a lower bound and an upper bound, and there was an equal chance of every number in between occurring. The second function is RANDBETWEEN, which produces a random whole number, no decimal places, between x and y from a uniform distribution as well. So as you can see from the table below, when we use the RAND function by itself, we can get a value of 0.11. This would be the random number from 0 to 1. If we wanted to generate a random number from 0 to 10 with decimals, we could basically take that same RAND function and multiply it by 10, and it will give us a number from 0 to 10. We could do the same thing for 100 and the same thing for 1000. The RANDBETWEEN function pretty much does the same thing. The only difference is that it is a whole number. So here we see an example where we have a RANDBETWEEN of 0 and 1, and it basically gave us a 0. And when we ran it again between 0 and 10, which turned out to give us a 0 as well. And finally, we have where we do a random between 0 and 100, and we will get a number between 0 and 100 as a whole number, which in this case was 1. We did the same for 1000 and ended up with 608. Now, it's important to note that the RAND function is volatile, and that means that when you run it, every time you make a change on your Excel spreadsheet, it can automatically calculate. You'll have to turn that off if you want to hold on to that number, or what you'll have to do is copy the value generated by the RAND function and paste it as a value. There's a separate video that shows how to do this in Excel. Let's say we're given a set of data with 100 test scores, and we wish to produce a random sample of 10 scores. Well, what we could do is randomly sample these 100 and say, give us 10. Now, the way we do that is we're going to assign each one of the test scores a random number using the RAND function. Once we have a random number for each entry, we'll simply sort them in order of top to bottom or bottom to top, and then take 10 numbers to obtain your sample, and this will give us a random sample of 10 scores. On the left here, we see that 20 out of 100 test scores were presented, where the second column was the result of the RAND function. What we did was we sorted them, and we could see that on the further right, we ended up with the numbers 76, 77, 94, 83, because the RAND function produced the random numbers between 0 and 1 and was sorted. We have the notion of a block random sample, and a block random sample basically divides the set into blocks based on the sample size you wish. So if we're looking for a sample size of 10, we would divide our previous example of 100 test scores by 10, obtaining 10 blocks. So the first 10 entries are in the first block, the next 10 entries are in the next block, and so forth. And this is equivalent of saying that we are going to select the kth entry of each block for a sample size of n. So what we might say is we're going to choose the fourth entry in every single block. And the number 4, would be randomly selected. So once we have our blocks, we can then choose a random number from 1 to 10 using the RANDBETWEEN function to tell us which entry in each block to select. On the right, we have used Excel to calculate which number in the block for each entry we want, 1 through 10, and this is known as the selection. In this case, 4 was chosen. And then what we can do is we can use the Excel if function to match the record in the selection and place an X to tell us which ones we were going to use. So this gives us the concept of the sampling interval, and it is the interval between selections. In this case, it's 10, otherwise known as the kth entry. So it's the kth entry, which is the fourth entry out of every 10, and the interval will be 10. You can also use a lookup function, the VLOOKUP function, to actually pull those test scores out and put them into another data set so that you don't have to do them manually. In a stratified random sample, what we might do is we create blocks, but instead of choosing, say, the kth entry, or we would choose a random entry from each block a little differently. So let's assume we have our test scores. However, we have 60 female students and 40 male students. What we might do is split the data into male and female students. If we took 50 random students each, it might not represent the data very well because we could have an overabundance of female or an overabundance of male, and our real ratio was around 60-40. So therefore, what we would do is we would split them into the female and male, and then choose 6 students according to the proportion from the population that are from the female group, and 4 students from the male group because the proportion of male students was 40%. Then this would keep our ratio consistent with the larger data set. This is known as a proportional sample size, so that the proportions were chosen from each entry is equivalent to the proportion of the population. Now, what we might also do is we might also use clusters. So what we might do is break up a sample set of data into regions, say demographic regions. We could even do it by medical conditions, or as on the right, we have regions of the United States. And there's no necessarily set way to do it, but you might do it based on some theory or based on some known attribute of, say, the country or state that is meaningful. So the analyst will have to make that decision. And what we would do is we would randomly choose from each one of these clusters. We would break apart our sample, put them into the clusters according to the regions, and then randomly choose the number of items that we need to make our sample size from each one of the clusters. We could also use proportional sampling to indicate the different proportions within the regions.